Hi, this is Ms. Jensen, and today we are talking about graphing rational functions. So if we're going to talk about graphing rational functions, we have to start out by talking about graphing the asymptotes. The asymptote is just the line the graph approaches, okay? And it's always dotted. So if we were going to graph the line x equals 4 on the x-axis, I'm going to mark 4, and it's just a dotted line, dotted vertical line at 4. We had a horizontal asymptote of y equals -3. At -3 on the y-axis, I would just put a dot. Okay, so those are not actually the graphs, they're just the lines that the graph is going to approach. Okay, so how do we figure out if we're given an equation what the horizontal and the vertical asymptotes are? So if we have an equation, the horizontal asymptote is just the number added after the fraction, which is 19. So we have a horizontal asymptote of 19. The vertical asymptote, if I set this denominator equal to 0, I get 7. And that is the vertical asymptote. Horizontal is -5. The vertical, well, if we set this equal to 0, 3x plus 12 equal to 0, 3x equals -12, x is -4. And we would go ahead and graph it from there. So if we're graphing a rational function, these are the steps we're going to follow. The parent graph is 1 over x. So step 1 is determine your vertical and horizontal asymptote. So that's what we were just practicing now. Second step, pick a value of x on either side of the vertical asymptote and plug it in to find a specific point on the graph. And you're going to draw two curves. So by either side, we mean one on the right side of the vertical asymptote and one on the left side. Okay, so we're going to start with this one, 1 over x minus 3 plus 1. This is our horizontal. Horizontal, so we switched before horizontal was first, but horizontal is y equals 1. If I take this and I set it equal to 0, I get x equals 3. So this is my vertical asymptote at x equals 3. This is my horizontal asymptote at y equals 1. Okay, so this is the graph from here. So I'm just going to kind of put in the middle, the vertical asymptote is 3, right? The vertical asymptote is 3. We're going to pick a point on either side. So one number to the left of 3 is 2. A number to the right of 3 is 4. So we're really just taking an x to the left and x to the right of that. But that's not actually going to be the graph, but we're just doing that to figure out our points. But then, of course, how do I figure out what y is? Well, if I know what x is, I can always find y by plugging it in to the original equation. So if I plug in 2, 1 over 2 minus 3, well, 1 over 2 minus 3 is -1. 1 divided by -1 is -1. -1 plus 1 is 0. Okay? So we plug this in to get our y. If I plug in 4, so plug in 4 for x, 4 minus 3, and the denominator is 1. 1 over 1 is 1. 1 plus 1 is 2, okay? So a lot of 1's there. So plug in x to get y. Okay, we're now going to plot those points. So I'm going to go 2, 0. So 2, 0, just by coincidence, it happened to be that one there. And then we're going to go right 4 up 2. Okay? And what should happen, I'm just going to get rid of this little one, is we should have points that are kitty corner to each other. So one in the upper right, in this case, and one in the lower left. Okay? So what should happen is if it's, if the graph works out correctly here, I'm going to move that around a little bit. It should pass through that point and then follow the asymptote, but it never crosses the asymptote. Okay? Let's try one more. So we're going to start out with our horizontal. We're going to go to our vertical. So if I go 3x plus 6, 3x equals negative 6, our vertical is negative 2. Our horizontal is negative 1. So this is always relative to the vertical. So if this is negative 2, I'm going to put just a little negative 2 there to remind myself I need to go 1 down from negative 2. So what we're doing is 1 to the left of that negative 2 asymptote, 1 to the right. So 1 at negative 3, 1 at negative 1. I'm going to erase the x's because those are not points. That's just kind of helping us know what to plug in. All right, but now that I have negative 1, I'm going to, maybe I'll just work one out here so you can see. So if I plug in that negative 3, 3 times negative 3 is negative 9. Negative 9 plus 6. Negative 9 plus 6 is negative 2 over negative 3, which is 2/3 minus 1, which is negative 1/3. Okay? We can handle that fraction. If I plug in negative 3, so now I'm going to plug in negative 3. I don't think I'll write it out again just to save space, but if I did plug in, pardon me, negative 1, I would go 3 times negative 1, so I'd plug it in here, which is negative 3. Negative 3 plus 6 is positive 3, and then I end up with negative 2 over positive 3 minus 1, which is negative 2/3 minus 1. I can just write it as negative 1 and 2/3. If I wanted to write it as negative 5/3, that's okay also. And those are the 2 points I'm going to plot. I'm going to go left 3, so from the origin, from the center, I'm going to go left 3, 1, 2, 3, and down 1/3. And then I'm going to go left 1 and down 1 1/3. So they should be about the same distance from where the x asymptote and the y asymptote cross, which they are. They should be kitty corner. One is upper left, so the other one is lower right. And then if we connect those, again, we're just trying to pass through the point and make them approach, kind of get close to the s asymptote. The x-axis and y-axis, both of them are asymptotes. You know, if I want to get picky, it's like, you know, I'm going to try to make that a little closer. Something like this. All right, but it should never cross the asymptotes. So that is it for the beginning of graphing rational functions. You're going to do the 3.2 worksheet.